This is a video demonstrating the use of the precision table saw fixture. That's what this is. If you look at it, you can see that it can be mounted to a table saw by using either the T-slot bolts, which are here in the base, or these magnets, which allow you to move the table saw fixture pretty much anywhere you want on the table, as long as it's still on steel. The fixture is adjusted by using this digital micrometer head, which feeds this roller, this brass roller, in and out on a close tolerance slot, dovetail slot in the base of the fixture. Now, I'm going to mount the table saw fixture to the saw. I'm going to use the ordinary T-slot bolts. Instead of the magnets. For this demo, now, in order to set up the saw and the fixture, what we'd like to do is have the fixture to the rear of the blade by some small amount, so that when the material goes through the saw blade, there is no bind between the roller and the blade with the material. So set it up to just to the rear of the saw blade a little bit. Doesn't matter exactly where it is. And make some effort to have it square to the front of the table. Again, not really that important exactly where it is. It could be a little off this way or that way. I doubt that there's a significant cosine error until you start to get it kind of tipped. But that's easy to see. You set it up there. I'm using a piece of MDF scrap. I've marked it with a rough location for the amount that we would like to take off with each cut. Assume that this is a piece that has been ripped to width, and we'd like to make consecutive, repeated, exact slices of this material for some reason. Whether you're making a butcher block top or something else, where you say, I want to have each piece come out exactly the same, repeatedly, over and over again. Take the scrap piece, your setup piece, move it in to the saw blade, and just kind of eyeball where the blade lines up, as you might normally do with a pencil mark on the scrap. Lock the fixture in place. Again, doesn't matter exactly where it is, just for the moment. And just for the heck of it, we'll zero the fixture. And that doesn't have to happen, but it's convenient. Then we'll start up the saw, and I'll stop talking because you won't hear me anyway. Turn off the saw, wait till the blade stops, and measure the material that we've cut off. Now, I said we wanted, for example, a 1-inch piece. This piece measures 1.086. So we know that in order to get an exact cut, we have to remove 0.086 from the front of the fixture. Because I had zeroed the micrometer head before the first test cut, it's a simple matter to just dial in the minus 0.86 that is necessary to arrive at the final dimension of 1 inch. As you can see, there's a considerable amount of resolution to this measurement. Probably not necessary for wood, but that's the way micrometer heads come. There we have our 0.86 that is necessary to be removed from the material before the final cut. Very simple to do. We'll take another cut. Blaze stop, reach in, grab our setup piece, take a measurement, and as you can see, we've hit 1.00, and 5/10,000ths in wood means nothing. So we know that now the fixture and the blade are in this plane, they are 1 inch apart. So that means that we can take our scrap piece, get rid of that, calling the good stuff, bring that into play, and once again start the saw. Again, wait for the blade to stop, grab one of our pieces, and as you can see, we're able to hit 1 inch, or very, very, very close to 1 inch in all of our material over and over and over again.